Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. So what is success? Success is not about the project success. It's also about the success of the people who are working. That means quality control engineer, site engineer and the civil engineer, how they will get success in their career. That all strategies also we are discussing in this channel. So this channel is all about the success of quality control engineer, site engineer and the civil engineer. So what is today's topics? Today's topics is very basic, but the most important material for our construction, that is cement. Without the cement, we cannot even think a project. Cement is everywhere, in concrete, in plaster, in brickwork, in flooring. So each and everywhere the cement is required. To understand this cement, you need to know the chemistry of the cement. So today's topics is all about the basic chemistry of the cement. So stay tuned until then to get the full information, and if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is basic chemistry of the cement. Now, whenever it's come to in your mind that comes cement, that we are always thinking about the concrete. It's not about the concrete, you just think about your projects. Everywhere is the cement. Cement is the main ingredient of concrete and of your project. So we are going to discuss about the cement. Now what is cement? Cement is a hydraulic binding material. It's the simplest version of the definition. It's a hydraulic binding material. Now there are two terms, that is hydraulic and the binding. Now first come to the binding. What is the binding? Because think about the concrete. In the concrete you have cement, you have coarse aggregate, you have fine aggregate, and you have to add the water, and after that it becomes the hardened paste and it's called the concrete. Now who is binding all these ingredients together and make it concrete? That is the cement. That's why it's binder. Think about the mortar, sand and cement. Cement is binding. Think about the plaster, think about the flooring work. This all area, it's binding all the ingredients and make it a homogeneous paste. That's why it's a binding material. Now another terms I told you that cement is a hydraulic binding material. Now what is hydraulic? Hydraulic means it reacts with water. Water is hydro, and all we know. So it reacts with water, that's why it's a hydraulic. And after reaction it hardens even under water. That means if when it reacts, it's become harder. So as it is react with water, it's called the hydraulic binding material. Now very important point to remember that cement is not the concrete. Sometimes we confusing that the cement has the broad strength and everything. So cement is not the straight concrete. Cement is only a raw material or the binding material for the concrete, and concrete is a homogeneous paste of different material, that is cement plus aggregate plus water, and aggregate in the coarse aggregate and the fine aggregate. So cement main job is to bind aggregates together and develop strength through chemical reaction, and on trying the chemical reaction is called hydration. So these are the definition of the cement. Now what is the raw material of cement? We cannot get it on the environment, right? We will go into the quarries and dig it out the cement. It's not possible. We need to prepare, we need to manufacture the cement. So what is the raw material of the cement? The main raw material of the cement is the limestone. So this is the cement chemistry that you need to know. What is the raw material of the cement? So cement raw material is a limestone rich in calcium carbonate. All you know that calcium carbonate is the CaCO3 and provides calcium, which is a backbone of cement strength. So limestone is the main ingredient, the raw material for the cement, that is calcium carbonates. And other material, clay or shell in the form of contains silica SiO2, that contains alumina Al2O3, iron oxide Fe2O3. So main is limestone and clay or shell, that is contains silica, alumina and iron oxide. And each material has a role. What is the role we have in each material in the cement? Calcium gives the strength, silica gives the durability, alumina it's the early reaction it started, and iron helps in manufacturing. Now, as we told that we are not getting it directly from the environment, we need to manufacture, हमको इसको बनाना है. So iron help in manufacturing in the cement. And finally, another raw material we have to use, that is gypsum. Now, gypsum is very less quantity in the cement, but without the gypsum, cement is production is not possible. Gypsum added during grinding to control the setting times, otherwise we cannot produce the concrete, and also it prevents the false setting. Now, if you want to know about the role of gypsum in the cement, I have made a detailed video, link is there or in the description, please check, you will get the full information. But in the basic chemistry, gypsum also you need to use in the very small percentage, but without the gypsum, cement is not possible to produce. And what is the manufacturer point of view in the chemistry? Now, at the high temperature, because this you need to form the clinker, and in clinker you need to heat this in on to 145 degrees Celsius. It's a high temperature, and the high temperature, what is happening? Limestone decompose, and the chemical reaction calcium carbonate is become calcium oxide plus carbon dioxide. This process is called the calcination. See here, carbon dioxide is producing. The carbon dioxide, all we know, that is harmful for our environment, and it is a greenhouse gas. So that is why during the production of cement, carbon dioxide manufacturing, and that is why the cement use is actually is harming the environment. That is why we are always replacing the cement with the GGBS fly ash, because it helps us for the sustainable construction, because we are, whenever we are producing, this carbon dioxide gas is increasing. So lower the percentage of cement used in the construction, lower the percentage of the CO2 emission into the environment. And so limestone decompose in high temperature, that is calcium carbonate turns into calcium oxide plus carbon dioxide, and this process is called the calcination. Then calcium oxide, that is CaO, reacts with silica, alumina and iron to form a cement clinker. This clinker is ground with gypsum to form cement. So first limestone has to decompose, and then this decompose is to add with silica, alumina, iron to make a cement clinker, and this clinker is grounded with gypsum to form the cement. Now let's see what compounds are formed. Now that we have the calcium carbonate and all we add, and we make the form the clinker and it decompose. Now what will happen? What is the main components of the cement, or we need to know what is the main ingredient of the cement. First things is we already know, that is the C₄AF, that is tricalcium silicate. This is the most important compound in the cement. So what is the role? Gives early strength. That means whenever you are adding water into the mix, this C₄AF start reacting with the cement, because cement is not only one component. Cement is also has the 4 components. One by one I will complete that. For the first component, what is start reacting with the cement water, that is C₄AF, that is tricalcium silicate. This is the most important compound. So it's early strength because it starts reaction immediately, so it will give the early strength. So whatever the strength the concrete is gaining within the 7 days, that is from the reaction with the tricalcium silicate. And what is the properties? Reacts fast with water, generates high heat of hydration, because the reaction is the exothermic reaction, it produces the heat. So the rate of reaction is more and the rate of producing the heat is more. So it produces the more heat. That is why it's called it's a heat of hydration is high. So that is why if our concrete is a mass concrete, when the heat is to be lowered, we need to choose the cement where the C₄AF percentage is less, because if the C3 percentage is more, the more heat will generate, because it will start reacting immediately and the faster reaction. So if C3 is high, although early strength is high, but heat generation is also high. That is why OPC gains strength faster rather than PPC, because PPC has a lower percentage of C₄AF, but OPC gives the more heat. Other hand, the PPC gives the less heat. Now, the second component of the cement is C₂S, or the dicalcium silicate, responsible for later stage. Now, water, we are adding water. The first up it plays with the C₄AF, that is from 1 to 7 days. Now, from 7 to 28 days, it start reacting with dicalcium silicate and gives the ultimate strength. Now, this is the second part. The first part is C₄S, second part is C₂S, and react slowly, generate less heat, and C₂S improves durability and long term performance. So, you need to balance C₄S and C₂S in your cement according to the requirement of your project and according to the area you are using the cement. The third component of the cement, C₄A, that is tricalcium aluminate. The compound reacts very fast. But what is the roles? Controls initial setting time. Now, all you know, the initial setting time is a cement properties. But today we are not discussing about the cement properties. We are discussing about the cement chemistry. So, C₄A is control the initial setting time. Why? Because within the initial setting time, we need to pour the concrete, because if it's beyond the initial setting time, it loses its plasticity and we cannot pour the concrete. So, what is the problem? You know what is the C₄S? Generates very high heats, poor sulfate resistance. That is why gypsum is added to control C₄A reaction. Now, I have told you earlier when I was saying how to produce the cement, we are adding the gypsum, very less quantity, but it's very much important that if gypsum is not there, C₄A start reacting immediately and produce high heat and the false set will occur. So, we will not get the concrete or will not get the strength as per the desired. So, that is why gypsum is added, and this gypsum is control the C₄A reaction into the concrete mix. So, gypsum is plays a very crucial role. Now, the fourth component is C₄AF, that is tetracalcium aluminoferrite. So, what is the role of this? Now, it is a minor strength contribution, helps in manufacturing and gives grey color to cement. Not very important from strength point of view, but that also you need this compound because it helps in manufacturing of the cement. Now, all we know that we have told that the gypsum we are adding. So, why gypsum added into cement? Or the initial setting time, and cement reacts with a very immediately with either for the C₄A. So, that's called the flush setting. So, remove this or the control this flush setting, we have to add the gypsum into the mixes. This gypsum is responsible to the control the reaction with C₄A, and it's not making the flush setting of the cement. So, gypsum reacts with C₄S and slow down the hydration process, gives enough time for mixing, transporting, placing concrete. Otherwise, what will happen? Immediately after the water, C₄A will start reacting with the cement and the flush setting will happen. The initial setting time will be a problem. So, we will not get the same concrete what we are desired for. So, what is the typical gypsum content? It is 3 to 5%. Now, what is the hydration of cement? Hydration of cement is the reaction of cement with the water is called the hydration of cement. It's simple because cement is only reacting with the water, not with the aggregates or with the sand. So, what is the hydration? Whenever it is C₄S or C₂S react with the water, what they are from? They are forming CSH gel, that's calcium silicate hydrate. This is the main strength giving compound, acts like glue, binds everything together, and then calcium hydroxide also is weak compound but necessary for the hydration. So, simplified reaction, but it is a complex reaction, but simplified reaction is a cement plus water, CS gel plus heat plus calcium hydroxide. So, important points that the strength comes from this, not from drying. So, whatever the CSH gel we are preparing with the cement, it is reacting, that gives the strength, not the cement is drying. So, So that is why curing is very important. Why? If the curing is not there, so water inside from the concrete, it will evaporate into the mix, and there will be a less water to react with the cement, and we will not get the CSH gel, which is responsible for the strength gain. Now, what is heat? Heat of hydration also a property or the chemistry you need to know about the cement. This is or what is called during hydration heat is produced or low. So this because it's a exothermic reaction, and this is the heat of hydration. This heat of hydration is not good for the concrete. It can causes the thermal crack into the concrete, because whatever the heat is producing, that should pass to the environment, because the first law of thermodynamics, heat loss and heat gain, if there is any temperature difference, so from the higher temperature heat will go to the lower temperature. So in the environment, if the temperature is low, it will transfer, and when it is transfer, it will generate the cracks in the surface. So C3 is very high in heat generation, C3 is also high, C2 is low. So how we can control the heat? Use PPC or PSC in combination with OPC, or use proper curing, or you in the mass concrete we need to protect, or we need to temperature control and temperature monitoring. And now another chemistry for this is setting and hardening. Cement setting is what is called cement. Cement setting is cement paste loses plasticity. When we are adding water, still sometimes we have the plasticity limit, or within the plasticity limit we need to pour the concrete. So in time it loses plasticity, and the called is the initial and final setting time. So if you want to know what about the initial and final setting time, I have a detailed video, you can check, in description is there. And hardening strength develop over time. So settings happen due to C3A reactions, hardening happens due to C2S C3 reaction. Now what is the practical site relevance for the cement chemistry? Fast setting concrete, if you want to know fast setting, high C3A or low gypsum, low early strain, low C3S or poor curing, cracks in wrapped foundation, heat of hydration, and sulfate attacks, high C3A content. So that is why QC engineer must understand the cement chemistry, that what is the cement compound and how it will react with the water, and how it will react with the environment, or how to do the chemical ions like iron, sulfur, carbon dioxide, and accordingly we need to choose the what type of cement. But before that you need to know what is the cement chemistry, that I discussed today, that what is the cement chemistry, what is the raw material, what is the main ingredient of the cement, and how they react with the water, and how much heat they are producing, and how much they react with the chemical. So these are all about this, and please in this you need to know the basic chemistry. This is the basic chemistry, because concrete technology is ocean and we know very little, but whatever I know, it's a basic one, and so that I am also sharing the basic chemistry, because you need to know whenever you are entering into the concrete industry, or you are entering into the construction, you need to know this basic chemistry for the cement, and accordingly you can choose cement for your concrete or your projects. And I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.